Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for exam P on probability. Upon arrival at a hospital's emergency room, patients are categorized according to their condition as critical, serious, or stable. In the past year, 10% of the emergency room patients were critical, 30% of the emergency room patients were serious, the rest of the emergency room patients were stable. 40% of the critical patients died, 10% of the serious patients died, and 1% of the stable patients died. Given that a patient survived, what is the probability that the patient was categorized as serious upon arrival? So one very important thing to notice immediately in this problem is that we are given the probability of patient dying given that that patient was critical, dying given that the patient was serious, dying given that the patient was stable. But of course, 1 minus the probability of dying is probability of the patient survived, so we also are given the probability of the patient surviving given that the patient was critical. That probability is 1 minus 0.4, or 100% minus 40%, which is 60%, or 0.6. Probability of the patient surviving, given that the person was serious, is 1 minus 10%, or 100% minus 10%, which is 0.9, or 90%. And the probability that the patient survives, given that the patient is stable, is 1 minus 1%, so 0.99 or 99%. And then we are asked for the conditional probability the other way around. We are asked for the probability that the patient was serious given that the patient survived. Anytime you see this flip-flop of probabilities, conditional one way in the problem and conditional the other way in the question, this is a Bayes theorem problem. You're going to apply the Bayes theorem to solve this problem. Remember, we begin by labeling the events, then figuring out the situation, and then working to solve it. So let U be the event that the patient survived. Let E sub S be the event that the patient was classified as serious upon arrival. Let E sub C be the event that the patient was critical. And E sub T, the event that the patient was stable. I can't use S because I already used it for serious. And we apply the Bayes theorem. So we are asked for probability of E sub S given U. The Bayes theorem says that that's equal to the probability of conditional probability the other way with these two flip-flops. So probability of U given ES times probability of ES, divided by the sum of all probabilities, just like the one in the numerator, but for all pieces of the partition of the probability space. And the probability space is divided here into patients that are serious, patients that are critical, and patients that are stable. These are all possibilities. They're mutually exclusive, so they form a partition of the probability space. So if you memorize the Bayes theorem formula, which you should, if you want to pass the exam, that is, then you write it out. Then every single piece of information for probabilities that are listed here is in the problem. So we have probability of U given ES. It's actually given as 1 minus 0.1, but it's 0.9. Probability of ES is 0.3. Probability of U given EC is 1 minus 0.4 or 0.6. Probability of EC is 0.1. Probability of U given ES times probability ES is the same as the numerator. And then probability of U given ET is 1 minus 1% or 0.99. And probability of ET is 0.6. And then we just do the calculation. We get 0.2922, which is answer B. And as always with the Bayes theorem, you can solve the problem by drawing this probability tree or diagram that tells the whole story. So the pieces of the partition of the probability space, the space of all patients, are critical patients, serious patients, and stable patients. And they have these corresponding probabilities of 10%, 30%, and 60%. And then for the patient who's critical, given that the patient is critical, probability of death is 0.40, probability of survival is 0.60. Given that the patient is serious, probability of death is 0.10, probability of survival is 0.90. Given that the patient is stable, probability of death is 0.01, probability of survival is 0.99. And here I repeat the calculation, but now you can see it from the diagram. So the top, the numerator of the fraction, is 0.9 times 0.3, which is the case when you have serious patient and survival. 0.3 times 0.9. That's the numerator, because that's the situation that we want. We want serious patient, and U corresponds to survival. And then the bottom has all paths that correspond to survival. So it's critical, 0.1, times 0.6 for survival of a critical patient. Serious, 0.3, times 0.9, the probability of survival for a serious patient. And stable, probability is 0.6, times survival, probability of that is 0.99. That's what you see at the bottom. So the bottom has all the paths that lead to survival, which is that event U after the vertical line, which is really the calculated through, the probability of it is calculated effectively through all possible ways of getting to survival in that diagram that you see there. Of course, it is exactly the same calculation. It's just by memorizing the formula. I'm giving you the diagram so that you can see also the working of it with the diagram, which you would use if you didn't memorize the formula. Like it or not, your most efficient way to the passing of exams is memorizing formulas. You want to understand everything. The diagram is very helpful for that. But most importantly, you want to be so ready on the exam that you don't hesitate, you know exactly what to do, and you have memorized the formula that you're going to use. I don't like memorizing things myself, but I would strongly encourage you to memorize important formulas, such as the Bayes theorem, because if you don't, you're going to compete with students who did. This is a very serious exam, and people who take it memorize important formulas. You need to be one of those people who are the scary, dangerous competitors who have everything memorized. Yes, indeed. And by the way, you will memorize things if you do a lot of practice problems. Seriously, with dedication. You want to do this. That's how you should study. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.